Hey everybody, welcome to another exciting episode of Data Exposed. I'm your host Scott Klein. With me today is Maxim. Maxim, how are you doing?
Good. It's been a while.
It's been a while. It was awesome having you on the show last time. It's good to have you back. For those that may not remember you, why don't you take a second and introduce yourself?
Yeah, absolutely. I'm Maxim Lukyanov. I work as a program manager in Big Data team at Microsoft, and specifically on Azure HDT Insight Service, working on our server and Spark.
Spark, okay. And so the Spark is actually why you're here, because we're going to talk about interactive Spark. Give us an overview of what that is. What is interactive Spark on Azure? Is that kind of spinning up an HDT Insight cluster with Spark, or how does that work?
Yeah, absolutely. So Spark is a fairly familiar thing in the big data world, and we can talk about it in a minute. But what's important about this, that's why we put interactive Spark in the title, is that it frequently there is a connection between productivity of people that use big data tools and the quality of the tools that they use, and specifically interactivity of this tool. So that's what is the topic of this talk today.
Okay, cool. All right, well let's jump right in. What do you got for us today?
Okay, well, so interactive Spark. Imagine you're a data scientist.
Okay. We all like to pretend we're data scientists, right? So, okay, I'm a data scientist today.
Okay. And as a data scientist, what would be your perfect day?
Good question. I'm a fan of, what's that?
It's hard, I know, to
imagine
you're a
hard
data
I could
scientist.
say my birthday, I could say Christmas, but I'm going to pick a off-topic date. Okay. I'm going to pick September 19th, because September 19th is International Talk Like a Pirate Day.
Oh, okay. Great. And as a data scientist, what would be your accomplishment in that day?
Oh my
From the professional point of view.
Oh, from the that's a good question. What would be our?
I should have told you in advance.
Yeah, exactly. That's right. No prep for this show. No. What would be my accomplishment for that day? Let's see.
What data scientists do?
They do data integration, data mining. They do analysis on data. Right?
Yeah, exactly. So you can imagine that you would have some hypothesis or some ideas that you want to prove. And as a data scientist, you would try to use data to either prove this hypothesis or disprove it.
Yep.
So that's your day. And the perfect day would be if in the end of the day you actually proved something new and learned something.
That we did X on Talk Like a Pirate Day, right?
Yeah.
Okay.
Oh, perfect.
Yeah.
We hit X on the Pirate Day.
Yeah.
Fantastic. So the connection that we are talking about is in fact, the data scientist work is actually an iterative process. Like in order to arrive at this final conclusion, you actually need to go through a sequence of experiments on your data.
Yep.
And the length of each experiment will determine your productivity.
Okay.
Like imagine, what would be your maximum productivity as data scientist? Can you guess? Like, what would be the speed of light of data scientists?
Oh.
How quickly can you make these conclusions? What would be the limiting factor?
Oh, hours in a day, how fast I can work, the cleanliness of the data, things like that, right? The amount of data.
Exactly, amount of data, all of those things play into the productivity of data scientists.
Yep.
If you talk about the speed of light, then all of those things should be perfect. And that means that every iteration just gives you answer immediately.
Oh, the perfect world, right? The perfect world says I get speed of light, I get the right answer, right?
Yes. If you get right answers immediately, then you're limited only by the speed of your thought. So you can, as a data scientist, your maximum productivity is determined by how quickly you can think.
Right, okay.
That's why you're paid so much as a data scientist.
That's right. That's why I rake in the big bucks.
Exactly. And in the big data world, unfortunately, that's not always the case.
Okay.
It's actually very easy to fall in the habit in the big data world of waiting for a big data job to complete.
Okay.
And imagine what happens to your productivity while you're waiting for a big job to complete.
Is that because we may not understand the data, or just the amount of data, or combination of all those things? We take a stab at it and we go, okay, well, and we get the output, and okay, this isn't what I'm expecting, so let's try again. And like I think that's our iteration, interactive. We had kept it going back until we get it right, type of thing, right?
Exactly, yeah. So it's iterative process, and every time you ask a question, you need to get an answer before you can ask another question.
Right.
And the primary factor in big data world is the size of the data.
Yeah.
If you're trying to ask a question to a few terabytes of data, well, it's expected that it'll take a long time.
Yep.
And that would basically destroy your productivity, because now you're waiting on these jobs to complete you cannot sync because you're
Click
waiting
go to lunch because I have to wait. Right?
Exactly, or drink some coffee.
Oh yeah, exactly. Because
So
I'm gonna be up a while.
yeah. So fortunately, and now we finally come to the topic. Fortunately, Spark on Azure gives you kind of a solution to that problem.
Okay.
If you're doing things correctly, if you're using these tools and tools that we provide in Azure, you can actually make sure that your day goes interactively and productively.
Okay.
And you can limit the length of the iterations at every phase of the development cycle.
All right, so this is the whole purpose of Spark, right? To be able to be more interactive, take that life cycle down short amount of time.
Yeah.
Okay.
And
good.
Spark as a computation engine was designed with that thought in mind. So it has great interactivity. Like if you launch Spark Shell, it by default is interactive. Every command that you type, if it doesn't involve bringing on a lot of data, it will immediately respond to you.
Okay.
So it's great in that regard.
All right.
It also has in-memory caching capabilities, which allow you to achieve this interactivity even on large data sets.
Okay. Yeah. Good. All right. So is this? It says is this natively? So when I, regardless if I'm working on like terabytes of data, this natively built in. Like, okay, it's going to be high performance, interactive. I'm not waiting that length of time. And is that just built in?
Yeah, that's a great question. So it depends. So you need to be smart of how you use this tool to make sure that it continues to be interactive for you.
Okay, so there's still some homework I have to do, some education I need to have in order to be able to still use it, best practices, we'll say.
Yeah, and we'll touch upon this couple of best practices in this talk.
Cool, all right, awesome.
Awesome. So Spark, I think we kind of introduced this. It has great momentum in the community. It's very popular. That's a kind of latest hot thing on the big data in big data world.
Until the next latest thing comes around.
Spark is here to stay.
Okay.
Until I move on to next project.
Exactly. Until I say, good.
Okay.
All right.
So,
all right.
So the next part of this big data environment where we work with data is actually Azure Cloud. So we put Spark in Azure Cloud in the form of a fully managed service, and we provide also all of the tools for all of the phases of data work, like data exploration, ETL, transformation, experimentation with data, and even sharing of your data with your colleagues.
Okay. So this is, assuming, if I'm familiar with spinning up an HC Insight cluster, this is almost the same thing. I'm just going to spin up a Spark cluster with HC Insight, right? Is that a true statement?
Yeah, that's right.
So it's a, if you're familiar with HC Insight, very similar. I'm just going to pick Spark. It spins up a Spark cluster, and I'm ready to go.
Yeah, and it comes with all the benefits of HC Insight.
Yep. So like managed service,
managed service. Yep.
Right.
Yeah, supportability. If you have any issues, you can call Microsoft, and we'll work with our partners, Hortonworks, who is a provider of distribution, Hadoop distribution, open source company.
Okay.
And there is also monitoring that is built in for your service. So if something happens in the middle of the night, there is an engineer at Microsoft who will go and fix it for you.
Oh, okay.
Yeah, so you don't have to.
All right, and as well as monitoring through the portal and things like that, right?
Yeah.
Okay, cool.
Exactly.
Okay, awesome.
Okay, so what's next on our agenda? Well, we can take a look at how it looks.
Awesome, demo time.
Demo time. Oh, fantastic.
Best part of the show. Not that we enjoy talking with you, but I love demos. All right, let's jump right in.
So in this demo, we'll go through all of these 4 phases of development experiences. First, we'll talk about how you explore data, kind of when it's raw and you just acquired it. Then we'll talk about how you share it. And finally, when it comes time to kind of build your production artifacts, you want to use some robust development tool that you can rely on. So we'll talk about that as well.
Yeah, and I think one of the questions, and you had it on the last slide, like what's the tooling experience for working with Spark, right? And from a development and like you say, development and debugging purposes, what's that experience like? So yeah, we'll get to that. Cool.
Cool. Okay, so let's switch to the demo. So I'll start. Well, let's do a little tour of the Azure portal, just to emphasize the point that you made that HD Insight cluster. The Spark is available as part of HD Insight. Okay. So Azure is basically a collection of services, and one of the services is HD Insight. And on HD Insight service, the primary purpose of that service is to give you a way to create these clusters, which run Hadoop or Spark or other open source bits. So it's very easy to create one. You just click a button and to follow through this wizard that guides you of how you create a cluster.
Okay.
So you can name the cluster. You can select the type of the cluster that you want, Hadoop, HBase, or Spark. Or we also have new arrivals like Kafka that soon will be in preview, Interactive Hive that is already in preview.
Okay.
So you select Spark, you select the cluster type, and you follow through the wizard. The important pieces to highlight here would be a pricing tier.
Okay.
If it works, let's click again. Yep. And this is basically how this cluster will look like. You select number of nodes of this distributed thing, and select type of the VMs that you want to use for each node.
Okay.
And you can select variety of the VMs that Azure supports, from smaller VMs up to larger VMs, including G5 series, which have plenty of RAM, plenty of CPU, so you can really put this thing to use for very computationally extensive.
And it's still pretty cost effective, right?
Yep.
And you can change these, once you can change the size and how many nodes you want. You don't have to stick with those once you've picked those, right?
Yeah, that's a great point. So once you picked it and created the cluster with the size, with the following size, yes, you're right. You can actually, after the cluster is created, let's open already created one. After the cluster is created, you can actually go and dynamically scale this cluster on demand. Like if it's a moment when you decided, hey, I need to run this experiment on this really large chunk of data, but I want to keep it short, you can increase your compute by scaling cluster. You can say, hey, I want to increase the size of this cluster from the current 10 nodes that it has to 100. Or you can go back and you say, hey, just scale it back to 1.
To 1 node.
I'm again playing with it. I don't want to pay for the compute.
Can you change the node sizes? Can I go from a D14 to a D whatever?
No, that is not possible right now. You'll need to recreate the cluster with the new node sizes. Yeah.
Well, I think, and that's not critical. I think a critical point is I can go from 1 to 10 just by changing the number and clicking save, right? Okay.
Yep.
Cool.
Okay, so that's important part. That actually helps you keep interactive with your data. But now let's jump into this cluster. So I already opened the window, so our demo goes quickly. So one of the first experiences that we have on the cluster is Notebook.
Okay.
Are you familiar with notebooks?
Yes,
it's a fairly new thing. So what notebooks basically allows you to do, they allow you to combine these descriptions and the code. So there are some cells that actually execute something, it's actual script. In this case, we are talking about Python that runs some Spark code. But you can also have charts and text, and you will see a little bit of charts later in the demo. This specific notebook demo uses data lake, which has a file schema ADL. And in this data lake, it stores a New York taxi data set. It's a actual real data set from New York City where it tracks various trips of the New York taxis. It's about 200 gigabytes inside, so it's fairly good sized for our purposes. And we can easily load and explore it, so that's the first task that we'll do in the notebook. So I just press Shift-Enter, and I can execute step-by-step these cells. So that provides me this interactivity experience. So in this case, I have a JSON, some large JSON file, and I can look at it fairly quickly and discover that, oh, this is something that looks like JSON. And if it's JSON, in Spark, it's actually very easy to convert this JSON into a table. So I can run queries on it and analyze it. So this next step actually converts this JSON file automatically into a table using Spark inference features. So it can just look at the JSON file and infer all of the columns that exist in this file. That's pretty cool. And once this is done, we can actually take a look at this data set again, but now in the form of the table. And this is where we use our extensions for Jupyter that we've built specifically for Spark, which actually visualize this table for you, and you can explore columns and see which columns you need, which columns you don't need. And that's kind of your first data exploration step. So you do some iterations of it, and as you can see, each iteration is very fast. So you can be very productive about it.
There was like 3 years of 2013, 2015 data up there, so I'm sure there's a lot of data up there. So it was actually quite fast.
Actually, we'll see how many rows in a second. So assuming that we've done this part, data exploration, the end result of this phase is some script where I say, hey, I decided of which exactly shape of the data I want to work with on my next step.
Okay.
So this step kind of represents this. Hey, we'll drop some columns, and we won't execute it because it will take a little longer because it operates, kind of crunches the whole thing.
Okay.
So the next step, we can now we have cleaned up rectangle of data, and we can work with it.
Okay.
And there are various features in Spark to help you work quickly with data, like Parquet. Format is a special file format that is compressed, it's column-oriented, which allows you to really run your analytics on these big data assets really quickly.
Yeah.
So that's one example. You can convert it into Parquet format. But another very important example is sampling. That's a very powerful feature for data scientists.
Yeah, I was just going to say, for data science, I want to take a small sample of that data to see, right?
Yeah, absolutely. And Spark has built-in kind of first-class support for sampling. So you just use this sample function, and here you go. You can create your sample.
1% of the,
in this case, we are doing this 1%. And all of the steps below, of course, will be very fast because if you are working on the sample.
Okay, yep.
That's great. And so what else? Well, then the next step would be trying to use this prepared data set, is a sample or the full data set, to understand it. We can build some charts that explain what this data contains, what relationships in the data there is.
Okay.
And again, we can use this auto visualization feature that we have to build a chart that represents, in this instance, a number of trips that depending on the number of passengers in the car.
Okay, yeah. Cool.
Yeah.
That's fantastic. So that was off the sample data, right? How many?
Oh, you notice? Yes, that's right. The interesting problem with samples that all data scientists kind of admit is that conclusions made on the sample are not always true.
Yeah.
Because your sample may be not representative.
Yeah. They skewed a little bit because it's only 1% of it.
Yeah.
In this case, 1%, right?
Yeah, exactly. So in Spark, you can also have an option to quickly validate your conclusions that you made on the sample by running the same query on the full data set. That's what we have here. And you would be surprised, but it also runs quickly because you can see here we cached this full data set in memory of the cluster. That's where we are using this caching.
So you took all that data and cached it in the cluster.
In the memory of the cluster.
Yeah.
So now I can afford running this query. It still runs a little longer than on the sample, of course.
Okay.
And my cluster isn't that big. It's just 10 nodes. But it's in a few seconds, still in an interactive manner. It completed this query, and quick. I can now validate what the real distribution of my passenger counts over number of passengers in a car, depending on the number of passengers, looks like.
So it looks like our sample was still fairly accurate.
Yeah, you're right. The distribution is the same. It's just the total number of users is different. Okay. So let's speed forward a little bit. So we can also take next steps. So this notebook as a whole actually represents end-to-end kind of scientific experiment. It starts with exploration, and in the end, it actually builds a predictive model. So let's go quickly through the steps. So one of the next steps that you might want to do is building some distributions over data that are more sophisticated than simple histogram. So that illustrates one other capability of Jupyter notebooks that we enabled is ability to run these arbitrary visualizations. There are many actually visualization libraries in Python community that work with Jupyter. And in Jupyter notebooks, you can invoke any of them and basically build a variety of visualizations that you need.
Right here in the notebook.
Right here in the notebook.
And this is just a sample of a couple of them, but oh man, this is fantastic.
Basically, you can see here we are using Matplotlib visualization library.
Okay.
But you can use any of the visualization libraries available. So that makes this very rich experience for kind of data analysis. So
very nice.
Jumping forward, there is some typical steps in data science process like preparing features, doing encoding of your data. We can quickly jump through those. You can see that every step here, I actually recorded the time, takes very little time. So you can go through the steps very quickly and finally arrive at your machine learning model. In our case here, we are predicting a tip amount.
Okay.
Depending on the number of customers, I believe.
Yeah, the number of passengers in the car.
Number of passengers.
In the car, yeah.
Passengers in the car.
Wow.
Okay, so that's kind of a first phase of end-to-end experience of exploring and building a predictive model in Python or Spark.
In Python and Spark. So, and this was, you launched this, going back to the portal, you launched this right from the portal, right? And then at that point, we could just start using Spark and Python right in here to just start getting our, our interactive. And like you, so I think this goes back to what we were discussing earlier, is that we didn't have to wait a long time to run and do, run Spark queries, right? It was very interactive, like you said, interactive, because it was very quick, and we didn't have to click go get some coffee.
Yeah,
right?
I'd like to drink some coffee with you, but in this case, we didn't have to because it's so fast.
It's so fast. And it was awesome because there was like 700 million, I think they said rows or something like that in there.
I didn't answer that question, yeah. So
okay.
we have some query here that counts the number of rows. So this one. So let's rerun this query. Okay, so
oh my goodness.
So it is 1 billion.
Oh, wow.
1 billion rows.
1 billion rows,
yep.
And we were still only able to do that full, because it was cached. The full the query on the full set because it was cached. Right?
Yeah, so we did it in about 6 seconds.
6 seconds.
Of course, it depends on the queries that you're running, but for simple exploration tasks, that's it's possible to even walk.
Okay, so quick question, because we need to wrap up.
Yep.
Is there like a playground? So if I spin up a Spark cluster, is there some place where I can say, hey, I'm sort of new to that, the notebook. Is there a place where people can go play, learn more about it, things like that?
Well, I would recommend starting with our documentation page. Of course, you can sign up just for Azure trial and start dive in and start using it right away.
Okay.
But you probably want to kind of familiarize yourself first. So you type HD inside Spark, and regardless of which search engine you use, you'll find an overview of Spark on Azure is inside.
Maybe we'll put this link in the description of the show so people have some place can quickly go to that.
That's a great suggestion.
Let's
do that.
Good. So going back to that last slide, so what you walked us through really was kind of that, data exploration, data sharing, so how we actually walk through those, and quickly how easy it was to do programming against that 1 billion rows, right, very quickly.
Exactly.
Okay, cool. Maxim, thanks for coming. This was fantastic.
Thank you for inviting.
I'm sure there's more we can talk about, but we'd love to have you back and talk more about Spark and HG Insight and things like that. It'd be awesome.
That's great. Look forward to it.
Cool. Maxim, thanks for coming. Everybody, hopefully this was helpful. I learned a lot. It was good. Learned a ton, actually. Thanks for watching, and we'll see you next time.